guys, today I want to talk about polynomial applications, aka word problems. And I know some of you probably hate them, some of you probably like them. So I will not tell you my opinion about them, but I'll give you some tips how to solve them. And we'll be doing some exercises together so you can have some help in understanding how to approach those type of problems. I'll give you some tips. With the word problems, first of all, you need to be extra careful and read this problem maybe 2 or 3 times, very slowly. Make sure that you understand every word because it can be tricky sometimes. Second tip, if you can use a visual aids, please go for it. Any diagrams, graphs, pictures, it will help tremendously. Third, be careful when you define your variable. Just make sure that this is the correct one. So take your time and cautious here. And the last one, probably, if that problem is kind of complex and has multiple equations, just do them step by step. Don't jump into the problem right away. Sometimes it's hard to see the final equation, so just take your time and go step by step. That's very crucial. So today we're going to solve multiple examples together. Most common ones in terms of revenue, maximizing area, I don't know, depends area, room area, different problems. So I have multiple of them. Let's see how it goes. So we'll start with a very common, typical type of problem, maximizing the revenue. So in our problem, we have a publisher who sells 80,000 of magazines per issue with $1.60 price, and now the publisher wants to increase the price in order to maximize the revenue. However, when they did a survey, the focus group, let's say, for example, they find out that for every increase in price, they will be losing 2,000 readers. So now the publisher asks, okay, so how much can I increase the price so I can get the maximum of revenue instead of be too greedy and lose much customers that you cannot support your business any longer. So first of all, what we need to do, make sure that we understand the problem. Okay, I have data given and what I need to find. So you need to have a clear understanding what you are looking for. So let's organize our given data first. Now, the publisher wants to increase price, and what he knows by increasing by 10 cents price each time. We will be losing, so amount of readers will decrease by 2,000 readers. By increasing price by 10 cents, we will be losing 2,000 readers each time. So that's our given data. The question is, okay, now, what am I looking for? Okay, the question is, what would be the maximum price publisher can go for to maximize the revenue? So we're looking for price max. Okay, so now first we understand the problem, we know what we are looking for. Now we need to define a variable. So first of all, I want to ask myself, okay, what's the revenue? What am I looking for? And revenue, you want to write the formula of the revenue, just the general one, to understand what it is. So the revenue, that would be amount of copies the publisher sells times price. So that's how you make your money. You sell something, you multiply quantity by the price, that's your revenue. So let's say this is amount times price, or quantity times price, as you will. Now, we need to define each of these components. What's the price and what's the amount? But first we need to understand what our variable will look like and what it will be in this particular scenario. So when I think about the price, right, it has also 2 parts. It has base price, which already been use, I know that we start with $1.60, otherwise it would be too pricey. And we know that publisher wants to increase the price. And we know by 10 cents, we will be losing 2,000 readers all the time. So let's say that X, that would be amount of increases. So let's put it in here, maybe use a different color. So let X be equal amount of increases in price. By doing that now, how our equation for price will look like. So we know the base price on why I keep going by 160, $1.60, and now our price will be, if we want to increase it by first time by 10 cents, that would be 0.10 times 1. If we want to increase by 2 cents, that would be 10 cents times 2. So you kind of understood already where I'm going with this. So that would be 0.1 times X. So let's just validate it. That, and I will want to put that in here. Again, our price function will be initial price time plus amount of increase, and we will be increasing by 10 cents all the time, and the amount will be defined that 10 cents times amount of increases we are actually doing. So that would be equation for the price. Now amount. So let's think about amount as well here. Amount, quantity, and we have to express it through X as well. So again, we start with something already given to us. This is our base data, so 80,000 copies. And now what's happening to it? So we know that it will be decreasing by 2,000 with every 10 cent of increase in price. So if we increase it by 10 cents, we're losing 2,000. If we increase by 20 cents, it would be 4,000. So again, every increase, which is X, will be losing 2,000 of readers. Losing means minus 2,000 times X. I hope that's clear enough at this point. Now, we already have our two components defined here, so we can go for our final equation of the revenue. I'll just put R of X, revenue, and we have these two equations here. So it's 160 plus 0.1x times 80,000 minus 2,000x. So we need to simplify the equation. I already did. I don't want to do that over again. So you open up parentheses and using distributive property, combine like terms, and you're supposed to get minus 200x squared plus 4,800x plus 128,000. Okay, so this is our revenue equation. Now we're coming back to the question, what are we looking for in this problem? And we're looking for the maximum price in order to maximize the revenue. So this is our revenue equation, right? So in order to find our maximize an X here, again, it's amount of increases. It's very important to remember what X actually represents, amount of increases. So if we find X maximum, we will find the maximum amount of increases in price in order to maximize the revenue. I know it's a lot of maximize maximum, but that's what it is. So what's the maximum of quadratic function? This is quadratic function, and it makes sense that we will be looking for maximum because we have a negative coefficient in front, so our parabola is downward, and our vertex is actually will be global maximum. So just to refresh your memory, hopefully you remember that, to find the x-coordinate of vertex, here's the formula, negative b over 2a. So let's do that. X max will be negative b, negative 4,800 divided by 2a, 2 times negative 200, negative 400, So minus minus gives us plus. We can reduce that, so 48 over 4. And that would be 12. Okay, so 12, again, what is the 12? X maximum. X is the amount of increases. So the maximum amount of increases we can allow in order to maximize the revenue would be 12 times. But it's not the price. So now, in order to find the maximum price, we just literally plug that value into our price equation. So let's do that. So P max of X will be equal 1.60 plus 0.1 times 12 times. So that actually 1.12 and 1.12 plus 1/6 is 2.8. So the maximum price a publisher can use in order to maximize the revenue will be $2.80 per issue. However, if he goes or she goes a little more, even already $2.90, that will not be already profitable anymore, because we know how our parabola goes, right? So I don't know, just the basic, something like that. So we going up, we increasing our revenue, we reach the maximum. I mean, they do not ask us to find the maximum revenue here, they just care about the price, so we don't have to do that. But if you want, you can. You just plug that value into your revenue equation, you can find it, it's totally fine. And after you reach that point, you're going down. So that's the whole point of maximum. So here's the answer, and that's how you actually solve majority of these problems to maximize the revenue. It's basically the amount of the goods of items you sell times the price, and that's how you find that. Okay, hopefully this one is clear enough, so we can move forward and do maybe a couple more problems. We have a rectangular dog pen is to be constructed using a barn wall. So we have a barn wall. Let's say it's a dog house. Maybe not. Well, let's keep it like that. Dog pen. Excuse me. Rectangular, right? So that's important. Again, every word counts, so be careful with every word. Alright, so we'll label one side as X. I just follow the diagram I have in my prints. Okay, so we want to build a rectangular dog pen. This is X side, and we know that this is a barn wall, and the sum of these three sides is 60 yards. Basically, this will be the fence we need to put on. So the first one, it has like 4 tasks. For the first task, we need to label other 2 sides, knowing this condition and knowing that side is X, which is pretty easy. So since it's rectangular, we know that would be congruent sides, so this is X as well. And so we know the sum of these 3 sides. Again, it's important because this is barn wall. We only care about the fence. So that would be 60 minus X plus X, which is 2X. Okay, so that's done. That's easy enough. So now the second problem, the task, if X equals 10, what are the other dimension of the dog pen and the area of the dog pen? Alright, so say if X equals 10, we need to find what's the other dimension. So obviously that would be also 10, 10, that would be 60 minus 2 times 10, 20, 60 minus 20, 40. Again, using congruency, that will be 40 as well. And now we need to find the area. So the area is length times width. I hope everybody knows that. That would be 400. Excuse me. So that's also pretty straightforward. Now we need to, the next one, they ask write a function formula for the area of the dog pen. So now we need to write a general formula. So so that was A, B, C. That would be, I guess, oh, that's C. Okay, that's C. So the general formula of the area is length times width. So this is X times 60 minus 2X, or 60X minus 2x squared, and I like to put them in correct order, so it would be negative 2x squared plus 60x. Perfect. All right, and the last question here, last task in this problem, find the dimensions of the dog pen that would maximize the area. Yeah, we need to maximize the area. We know the equation of the area depends on the side x, and we need to find the dimension which will maximize the area. So we need to find the max x. So that would be out of one of the dimensions. Unless we know one, we can easily find another one. Again, this is a quadratic function, and again it goes downward, which makes sense because we need to find maximum. Otherwise, that would be wrong. All right, so we already know the formula. So the formula of x max, it's negative b, negative 60 over 2a, negative 4, negative, it's positive, and here we have 15. So 15 yards would be our maximum width. So let's find our length. Now let's put W as a width and maximum. So we know that would be 15, so 60 minus 30 will be 30 yards. Okay, so if we do 30 times 15, it would be 30 times 10, 300, plus 30 times 5, 150, so it's 450. So it's more than 400. It's 400 we found originally here, so it does increases for sure. So and I believe we did everything right. I'm sure we did everything right, so that makes sense that those are the dimensions which will maximize the area of the dog pen. Okay, any questions here? I hope not. If you do, please comment below in the video and I'll answer on all these questions. This problem was pretty straightforward, so now I want to also do one more problem which will include Lagrange interpolation. It takes longer because there is a lot of calculation. It's not hard, it just takes some time to do that, and be very careful with calculation. So let's do it. So hopefully you guys familiar with this. If not, I probably will make one of the videos explaining how to do that. But I think even doing this problem right now, you will get the sense how to build the polynomial based on the data is given in the chart or table. So here's the problem. Just a heads up. Okay, I cannot draw nice pictures, so forgive me, but I'll do my best because I cannot draw this guy isn't here, but I'll do my best. Okay. So let me just do it here quickly. It's just a picture for the next problem. Again, I did tell you that I'm not that great, but hopefully it will be clear enough. Okay, that's a human being. Let's say that's a human being. It's a boy. All right. So the problem called diving board problem. Listen carefully. When you stand on the diving board, this is a diving board, everybody, the amount of the board bends. So amount of the board bends is defined as B. So this is a bend. Below, its rest position is a cubic function of D. The distance from the built-in end to the point on the board. Suppose to the end point. Suppose that you measure the following deflection. So we will have a chart of data here given, but again, let's go back to the problem to make sure that we understand that. Maybe I didn't read it well enough. So amount of those board bands, B, that's what we actually defined as a function of D, which is the distance from the base where this diving board build to the end point. So this amount of bend depends on this distance. So we given a chart, and we know that's a cubic function. They already told us. So we have here distance in feet. So it's 0, 1, 2, and 3. And we have b thousandths of an inch. So that would be 0, 116, 448, 972. So obviously, and there are multiple tests they want us to do. There's actually only two. Derive the particular equation expressing b in terms of d. So we basically need to find the function of this bend amount, depends on the distance. And the second one, the board is 10 feet long, so basically they want us to find particular values, when certain values given. But we'll get to it once we get the equation. That's the biggest part. So here again, when we give a chart of inputs and outputs, and we need to make a polynomial here, the Lagrange interpolation comes to rescue. We know that it's a cubic function, so here, which helpful. So now we have this table, so let's break it off into the multiple ones. So that would be equal to, so here will be 0, 0, 1, 0, 2, 0, 3, 0, plus, that would be 0, 0, 1, 116, 2, 0, 3, 0, plus 0, 0, 1, 0, 2, 448, 3, 0, and the last one, 0, 0, 1, 0, 2, 0, 3, 972. Okay, so we broke off this table into the sum of multiple tables. Make sure that it actually matches to that. So here we have 0, 0, 1, 116, 2, 448, and 3 is 397. Oh, I'm sorry, 972 when we add it up together. All right, so the next step, we need to make an equation for each of this with a coefficient in front. So for the first one, it would be a x minus 0, x minus 1, I'm sorry. For the first one, I should have said x minus 0. That's confusing because we have 0, 0, so it does confuse us a little bit. So we go by x minus 1, x minus 2, x minus 3. The second one will be b x minus 0, x minus 2, x minus 3. Third one, c times x minus 0, x minus 1, x minus 3. And the last one, d, x minus 0. And you could have just said x, but I just like to be consistent. X minus 0, x minus 1. This is basically 0, so we factor in these zeros. X minus 2. So now we need to find all these coefficients by using given point we have left. So here will be 0, 0, here will be 1, 116, 2, 448, and so on. So we'll just couple of this. So for a here, we need to plug the point 0, 0 equal to 0. So that would be negative 1, negative 2, negative 3 times 8 equals 0. So we need to multiply by 0 to get 0. So that's easy. A equals 0 here. So b, let's do b together, and after that I'll just give the answers. So we go by this point. So we plug a 1 into here, so there will be 1, let's just do it 1 minus 2, negative 1, 1 minus 3, negative 2, and it's supposed to equal 116. So by simplifying that, it will be 2 to b equals 116. So our b is equals 58. I don't want to calculate it right now to spend a lot of time, so you got the logic, so I'll just give the answers here. So the C is negative 224, and the D is 162. So once we found the coefficients, we literally just need to simplify each polynomial. I'm not going to spend so much time on that because it does take quite a while. Just a heads up, be very careful when you simplify like terms because you can get mistake very easily. I'll just give the answers again right away. So here, when a is equals 0, so the whole polynomial is 0. So that's basically gone. We don't have that part. So if this is, let's say that it will become 2, if it's 1, 2, 3, and 4. So the second one, after simplification, will be 58x cubed minus 290 x squared plus 348x. The third one, after simplification, again, in order to simplify, literally take this value here, open up the parentheses, use the distributive property, combine like terms, and you're supposed to get this the same. So the third one will turn into 162 x cubed minus 486 x squared plus 324x. Oh, I'm sorry. Alright, so that was the second one. Okay, so the third one, I already jumped into the last one. That would be negative 224 x cubed plus 896x squared minus 672x. And the fourth will be 162x cubed. I just wrote it in erase, 486x squared plus 324x. Okay, so now we have to add them all together in order to find the final equation. So, and that would be our function f of d. That's what we actually need to find. F of d, function of d, distance, in order to find the amount of how much the diving board bends. We'll just add them all together. I already did it, so my answer is negative 4x cubed plus 120x squared. So let's just double check that everything is correct. So here we have negative 224 plus 162, so it gives us negative 62, negative 62 plus 58 gives us negative 4x cubed. Okay, that's good. So 120, so let's make sure here is right. 896 minus 486, so 0, 1, 4 for 10, and 410 minus 290, 410 minus 290, so it's 120, so that's correct. And we need to make sure that this one is actually cancelled out. So it's 472, so if we add those, it has to be 472, so it's 12, so it's 67, and 672, so that is correct. So we answered on the first question, find the actual equation of the B depends on D, and that's what we did. And the second one here, the board is 10 feet long, so let's say if it's given, so the board, not X, I'm sorry, yeah, so out of habit. So let's say our board D, that would be distance, is 10 feet long, so that's our distance D. How far does its tip sag below the horizontal? So since we already know the equation, we can easily find it just plugging the value in. So our function of D, which is amount of the bend, it will be negative 4 times 10 cubed plus 120 times 10 squared. Okay, so after the calculation, if I just that value, it would be 8,000. 8,000 of an inch. So that's all. That's how you solve that type of problems. They're not hard. It's just a matter of time and being careful of putting those polynomials together. Okay, so room dimension problem. The length of a room exceeds the width by 5 feet. So length, width. Now we know that the length of the room exceeds the width by 5 feet. So if our width is x, then the length will be x plus 5. Okay, it exceeds. And the height is 3 feet less than width. 3 feet less than width. X minus 3. Why did I say 5? 3. Okay. The area of the 4 walls exceeds the sum of the areas of the floor and the ceiling by 240 square feet. Again, the area of the 4 walls. So we have walls. Just imagine you have a room, you have 4 walls, right? So the area of all these 4 walls exceeds the sum of the area of the floor and the ceiling by 240 square feet. Okay, so we can write it and just figure it out later using the variables, so we can do it right away on the fly. So let's think about that, how we can express it. So area of the 4 walls. So every wall in the room, let's even take this room for example, it's length and width. So the room is obviously rectangle usually. So we have 2 walls the same and another 2 walls the same. So let's say 2 walls 1 plus 2 walls 2. Area. No, actually, I would say better this way. 2 areas of wall 1 plus 2 areas of wall 2. Greater than sum of areas ceiling and the floor, and they're supposed to be the same, right? Ceiling and the floor again, just picture that in your mind. They're supposed to be the same, so it's minus area of floor or ceiling. Oh, floor plus ceiling actually, I would say, because it's 2 of them, floor plus ceiling, and they are the same. And by 240. Okay. Find the dimensions of the room. That's what we need to find. Okay, so now we need to express our areas of the walls and area of the ceiling and the floor using these terms, and we will get our equation. You just have to be careful here. So when we think about the first wall, let's think about this wall. So I have length and height is a width, right? So we have the height and we have the length. So that would be my width for the wall. So area of the first wall will be, again, width x times height, x minus 3. And we have 2 of those. So for the second wall, our width will be a length. I hope I don't confuse you guys. I'll explain it again a little later. Area of second wall, it will be actually width times length. Length times height. Yes, so we used width times height. Now it's length times height. Again, and we have 2 of this. And now we have ceiling and the floor, and they're the same area of ceiling or floor. So we have floor, let's think about that, or ceiling. So it's length and width. Length times width, area. Length times width, or here it's like x plus 5 times width x. Okay, I hope I did not confuse you, but again, just think about the room. I said that I'm not great at drawing, but I'll do my best. Okay, so, oh, and like, this has to be like that. All right, so this is a room. We know that for the room, we have, say this is length, well, for the room, this is length, this is width, and this is height. Height, length, and width. So now we talk about 4 different walls, right? So let's talk about this wall and the same wall on that side. So our area would be height times length of the room. And that's what we did. So length times height, that would be this one. Now we have these 2 walls here, right? So the area will be, again, if we look just at the rectangular here, forget that this is the cube in the room. So it would be width of the room times height, again, to find the area. This times width. Width times height, or length times width in terms of this particular rectangular. So that would be our width times height, and that would be this. So now we talk about the ceiling on all the floor because they're the same. So we look at this bottom or the top rectangular, right? So that times this, and this is length times width. And that's exactly what we did. Okay, so now we know that we have 2 areas of those, 2 areas of those. We know the sum of 4 walls, area of 4 walls, is increasing the area of the ceiling and a floor by 240. That's our equation. We found our area, so let's just literally go and plug that in here. So first area of the first wall is x minus 3. We have, again, I already mentioned 2 of those, so that would be 2x, x minus 3, plus, now area of the second wall, again, 2 of those, 2x plus 5, x minus 3, minus, or we can just, well, let's keep it that way. Minus 2 areas of those, that will be minus 2x, x plus 5 equals 240. Okay, so we made an equation. Again, let's go back to the problem and what we need to find. Ask ourselves, we need dimension of the room. We need to find dimensions of the room. So once we find x, we can find everything else, all right? So we just need to go ahead and open up parentheses and you know what to do. I feel like I already have the answer, so we don't have to spend a lot of time here. So that would be 2x squared minus 6x plus 2x plus, actually, you know what, let's do that way. Plus 2, and we open up those parentheses first. X squared minus 3x plus 5x minus 15. And that's still inside of this parenthesis, minus 2x squared minus 10x. Okay. Now we have 2x squared minus 6x plus 2x squared minus 6x plus 10x minus 30. And let's just keep this one here. Now let's combine the like terms. So we have 2x squared minus 2x squared, so that would be canceling each other. So we have only 2x squared. Now minus 6x minus 6x minus 12x. So that's canceling each other. So we have minus 12x. And I feel like we only have 30 left. Okay, minus 30. Alright, so let me check if I get everything right. Minus 2x minus 12x. Yep. And we know that it equals 240. Alright, so now we have our, we just move to 40 and get quadratic equation so we can find the solution. I'll just bring it up here. Okay. So it's 2x squared minus 12x minus 30 minus 240 equals 0. So let's just rewrite it real quick. Minus 270 equals 0. So you can use either way how to solve quadratic equation. There are multiple ways. But I already did, and our zeros, aka solutions, is 15 and negative 9 for quadratic equation. However, you know that since we're actually working with word problems, actual problems, we're talking about the root dimensions. There are no negative values. We cannot use negative values. There are no such a thing as negative width. So, not applicable for this particular scenario. So, we know that our x, which we went by width here, is 15. So now we can find our length. Width, length will be x plus 5, will be 20. And the height will be x minus 3, which is 12. Height, width, and length. And it doesn't look like we did it correctly, at least that matches, so that's how we solve that problem. Alright, there are much more complicated problems I have, but at least to understand the basic, I feel like we covered enough. This is the most common problems you will see in textbooks, like maximizing revenue, maximizing the dimension, or finding the dimension, or finding the formula polynomial based on Lagrangian interpolation. So I hope that was helpful. Again, be careful with the word problems. Just make sure you understand the problem. Make sure you understand what you're looking for, and just take your time and go step by step each of the all the way through. So don't rush. And it's okay. Do not understand or do not see the solution right away. So that's why I'm saying just go step by step. Alright guys, if you have any questions about these problems or any other problems, please comment below, like the video, and hopefully it was helpful. Hopefully it was helpful to you, and I'll see you later.